Hello, and welcome back to Learning with Lee. In today's episode, we are going to continue our discussion of loops, and in particular, the while loop, by focusing on this program here, which is designed to find the square root of some value via binary search. We already introduced this in the previous episode and went over what binary search was. However, we didn't cover how you would then implement that binary search. And that is where we are going to continue today. We are going to start off our discussion with these three variables up here. What these are, if you remember from yesterday, are aspects of the binary search, such as the threshold that I mentioned, so as that we don't end up having an infinite number of iterations trying to find the exact square root, but we go, okay, this is good enough. For now, I have it at 0.5, we can adjust this as we go, and I'll show a couple of examples like that later on in the episode. We have the square root, which initially is just going to be it's going to be used as our guess as to what the square root is at each of our iterations. And at the end of it, it should be a close approximation of what the square root is within this specified threshold. Then we have the delta, which is, if you remember how it was, saying that we started out at 1 to 100, and we started out at 50, then we would end up with, okay, we have our value in here of, basically the next one will either be 25 or 75. So our delta there is 25. Delta isn't necessarily the most accurate description for it, but at the same time, it's a good enough one to represent the difference between where we are and where we're going to be on the next iteration. Then down here, you can see what I already went over briefly in the previous episode, which is our termination condition. What, when it is false, will cause us to end this while loop. And in this case here, it's when our search delta happens to become smaller than our threshold, this will produce false, which will cause our while loop to exit. So that allows us to ensure that we'll keep searching until our binary search delta happens to be smaller than the threshold, meaning that our square root, or our guess at it, is within the threshold of the actual square root of the value. Up here, there are many ways in which you can comment a while loop. And there are many things that are useful to know about what's going on in a while loop, certain things that happen to be a bit unnecessary or providing more information than is really necessary and thus taking up space. But in general, you at bare minimum want to have an overview of what a loop is doing. And this is not just do this step, then this step, then this step. In this case here, it's saying we're searching for the square root of a value via binary search. One of the things you'll encounter is what are known as preconditions and postconditions, and they happen to be optional things to include here, but there are very good uses for them, and typically they'll be shown in different ways, especially once we start dealing with C# and we look at some of what is already supplied for us in terms of automatic comment generation. Preconditions are what your input must be for whatever's down here to function correctly. So in our case here, we need our value to be between 1 and positive infinity. We don't want between 0 and 1 because then our square root will be larger than our value, which would mean that we'd have to slightly modify our algorithm here. It wouldn't have to be a significant modification, but we would have to modify it. Then we want square root for what we're starting at to either be 0.0, because that's one option, or it has to be value itself. And the reason for that is that one of the first steps that we're doing in here is we're adding or subtracting the search delta to square root. So that'll get us to, in case we start out at 0 or 100, to 50. So we can begin our search for the square root of 100 that way. Then we need to have a threshold that is greater than 0, so because in case it's 0, we're going to end up with this going to potentially having an infinite number of iterations of that. I'm not going to say that will go to there, because just because it can go to there doesn't mean that you can't pick a specific value for which it will terminate before reaching an infinite number of loops. So there's that. Then we have our postconditions, and these are things that are true once we are done with the entire while loop. So first off, just stating value is unchanged, saying that our while loop will not affect whatever is supplied up here. This in general, it happens to be really useful for letting other people know that, and we'll get into some keywords that you can use in order to show that when we get into functions and methods. But it still is a very valuable thing to let people know that you aren't going to be altering something. Then, for square root, just saying that it will be within the threshold, or more accurately, it will be exactly within a search delta away of the actual square root of the value. Because at that point there, since this one will be smaller, it'll actually use that as its effective error margin. And then we're also saying that search delta will be less than or equal to threshold. So all of those are valuable things to understand about what is going to be true after your program has run. And really, these are all designed in order to help other programmers who are reading your code understand what you are trying to do with it, because what might be clear and obvious to you won't necessarily be clear and obvious to other developers. One minor change you might have noticed from the last one till this one is I moved this search delta up to here, and I changed search delta up here to value itself. And the reason for that was that in order to get the correct number of iterations, I needed to make those changes, because previously I had search delta divided by 2 down, well, divide equals by 2 down here. However, when I did that, you would get one too few iterations over what you were actually looking for, because of the fact that it needed to compare this so as that the search delta basically was the same as the level that you were on. So in case your delta was 25, you need to be heading to 25 or 75 at that same time for you to guarantee that you were within that threshold and within that search delta. Otherwise, your search delta would actually be smaller than your effective search delta. The next thing, in case you remember how I said, if we happen to be the entire process of splitting 100 down into 50, then 50 down into 25 to 0, or 25 to 1 really, and so on and so forth, this is what does that operation here. So, in case our square root is less than our value, we can get rid of all the things below our current estimation of the square root. So we add in the search delta, and then in the next loop it'll be half that amount, so as that we happen to be bounded between whatever our previous square root was and whatever then the next maximum up is. However, if our square root is too large, we need to subtract the search delta. And if you need to, go back over some of the previous episode right now so that you can get a good refresher or your notes on how binary search works in order to see why this is the case. But it should be relatively clear. And then this is purely something for debugging and to help us visualize what's going on in here, so that we can see what our guess is, what the delta is, etc. So I'm also then going to output down here, just so as we can have one final thing of saying what the final numbers are. Technically, we will get one of these to represent the final value, but it just is a bit nicer and cleaner to have this down here. So, let's build it. Shouldn't have any problems, run it. And, as you can see down here, it ends up saying that we're at 9.76, which happens to say that we're within 0.39, which is accurate, because what we're looking for is 10. So now let's say that I really want this to be accurate. I want this to be 0.005. And one of the other things you might notice is how many iterations this took. This only took 1, 2, 3, 5, 6, 7, 8 iterations, as opposed to if we'd say started at 0 and started counting up to 10, we would have ended up needing a significantly larger number of iterations, though in that case we would have had the exact answer. So let's try this, build it, run it, and it gives us this, of nearly 10. So pretty accurate, pretty good. And beyond where we were at the previous one, it only took, let's see, an additional, was that 5 iterations? Yep. Oh no, 6 iterations, sorry. But now let's try something a bit more complicated. Let's go with something like 10,000. to see how few this actually requires. And you can see right here, goes down, goes down, goes down, and it only takes 6 iterations for it to get, well, technically it's the 7th iteration that is under 100. So it's pretty quick for actually making it down there, and you can even go pretty large on some of these, so I could do like that large and it wouldn't have a real problem. I could input something like pi, so 3.14159, build it, run it, and reasonably good approximation of the square root of pi. So let's take a look at a couple of the changes in here to see how we could actually affect this while loop. So I'm going to actually, for simplicity's sake, drop this guy back up to where he was originally. Go back to 100 up here, 10 squared. Then we're going to build this and run this just as we can take one more quick look at it. Take a look down here. And the important thing really is that what I'm going to do, I would expect right now is that with the change I'm about to make, we're not going to get this final line here. So I'm going to go back to how I had it before, where the search delta is the value divided by 2.0. And then I am going to take this back to where I had it in the last episode, at the very bottom here. And as you should note here, it will more than likely give us this 10.15 with a delta of 0.78. And it's important to remember that delta is effectively our margin of error. So if you look here, did this, however, because of the fact, and this one here was the final one within this loop, which is important to remember because what we're doing is we're having this division here, so it keeps that same guess, but it reports this delta for that guess, which is inaccurate because this guess has this margin of error, whereas this margin of error actually would apply for our next guess, which is the whole reason why in between last episode and this episode I made the changes like this to fix that problem. So one of the other things that you might wonder is why are all of these out here? They're related all to this while loop. Well, you might remember what I had mentioned about context and with regards to scope. So in terms of scope, what I said was that if I declare something in here, we'll just call it int I, and we'll set it equal to 0. The important thing here is that I only exists within this scope. And as soon as you leave this scope, I is destroyed. So you can't use it down here, for example. However, here's the thing. You're entering and exiting this scope with each while loop. Because what you have to think about it is that there's effectively 2 different scopes at work here. This while statement is in this larger outer main scope, and this is its own secondary scope that occurs after the while statement. So this area in here has no knowledge of anything that gets created in here. What's in here, though, does have the ability to affect its surrounding scope, like I showed in an earlier episode. As a result, if I were to, say, move one of these from up here and just put it down in here, first off, we would get this error here, because it can't find it at the same level of scope that this while exists at. Alternatively, if I were to take something such as the square root, which doesn't exist anywhere else, and stick it into here, what we would wind up with is, ignoring the errors down here by just commenting that line out, an infinite loop. Well, actually, it wouldn't be infinite. It would give us, effectively, the same thing over and over again, just approaching 100, because what it would do is it would go, okay, we need to subtract the delta. And it would hit this, then it would go back through, reset it to value once it came up here again, and continue to do that every single time. Furthermore, as you could guess from the errors down here, square root doesn't exist outside of our while loop. It only exists here, so we can't actually use it for anything meaningful like outputting what the final value is. Which is why, when you do something like this, you need all of these to exist outside of the loop themselves. So what I'd like you to do is spend some time messing around with this file, changing things up, and getting a feel for the while loop in here. I'm going to end up uploading this either to a different site where you can download it, or I'll just put the text in the description. Be certain to take a look in there, and it'll have one of those two. Alternatively, you can write this down yourself and spend some time on it. However, what I'd like you to do is two different things with that file in particular, once you've gotten a good feel for it. The first happens to be, I'd like you to, if you remember in the previous episode I mentioned how there were two different termination conditions you could use for the while loop in this binary search. The first is the one that I'm using here, in which we happen to be doing effectively saying that our guess happens to be within a certain delta of the actual value of the square root. The alternative is that the square of this value is within a certain delta of the actual value. So what I would like you to do happens to be to find a way to compare effectively this square of our test square root to the value, make certain that it's within the threshold, but only do this multiplication of the square root times the square root once per iteration. It might seem a bit weird, and you might have to think a little bit about it, but trust me, it is possible to do, and that's one of the two things. The other thing I would like you to do, and this one here is going to be a bit more challenging, is see if you can figure out what you need to do here and make the changes to it so as that you can actually do this, so as that it now not only is between 1 and positive infinity, which is how this currently works, because in case I go to something like 0.8 or 0.9, then it's going to have some problems. However, you're going to need to figure out how this needs to change, how we end up changing the delta, etc., and how we end up changing the assignments up here in order to allow for that to happen. So, with that, I'm going to leave you for today. Thank you very much for watching. I hope you have a wonderful day.